Okay, it's week 3 of the notes. Material covered. We're certainly encouraging all students and instructors that are using these documents to cover what we're suggesting that needs to be covered. All right, so the bottom line is at the end of week 3, there'll be a couple of things that need to be done. Certainly, we're expecting after you finish the lecture week 3, watch the examples that we present to you and do the supplemental exercises. You should be able to do Math 119 week 3 in WebAssign. All right. Also, the weekly discussion groups. Again, you may just want to stop by during office hours and say something. Try to show that you're actually participating by saying something. All right. The other thing I wanted to point out is that there's going to be an exam 1. You'll get an email from me. All right. So make sure you're receiving the emails from me. In the email, I'll tell you when that exam is going to be scheduled. I'm not ready to schedule it yet, but once I'm ready to schedule it, I'll let you know by an email. And you'll be giving a window of opportunity to finish that exam. It's timed though, right? It's timed. What does time mean? When you open that exam up, the clock starts ticking. You're on the honor system now. What does the honor system mean? You need to tell me that you're willing to be on an honor system. What does that mean? That you're going to be honest. All right. So what we want you to do before you take that exam, and you should do that probably today after class, you should sign this honor document. Now, that big question is like, where's the honor document? Remember, these things are linked. So if you click on this over here, it's going to bring you to the honor code. Now, what I suggest you do is you print it out. Now, what page is that on? Page 18. So I'm going to just show you what that looks like on my computer. Whoops, I can't do that. I'm sorry. But anyway, you print out page 18, print your last name, first name, and your student number down. You should read through this, right? The honor code is a statement on academic integrity. It articulates reasonable expectations of students and teachers in establishing and maintaining the highest standards in academic work. All right, let's go through it. You shouldn't give or receive aid on an exam. You just shouldn't do it. The exam that you're taking is your work. Don't cheat. Don't ask someone for help. Don't go to the internet for help. Don't ask your calculator for help. You're on your own. If you've done what I've asked of you, which is the 10 lectures, pay attention, do the supplemental exercises, and then do the WebAssigns, you should have no trouble on this assessment that we're going to give you. All right. So I would say bottom line is this honor code is, please, when you submit the exam, make sure it's your exam, not somebody else's exam. All right. You should sign it. And what does it say? An electronic form of this is fine. So what do you mean by you print it out, fill out the information? What information? Last name, first name, yes, use your real name. Student number, yes, use your student number. Sign it. You should have a signature. And then what you're going to do is you could scan it or you could take a picture of it, but you need to submit it electronically. Where should you send it? To my address. What's my address? B as in boy at nnon.us. That's where you're receiving emails from me. Send it to me. When I get it, what I do is I put it in a folder and it's there and it applies from now until the end of the semester. You just have to do it one time. By the way, if you can't do it for whatever reason, let me know that. All right, let me know that. All right. Okay, so I want to go back to the notes. We talked about this. And, someone says, oh, what section? I can't remember that. I got so scared with that honor code thing. We're in week 3, right? So what did I talk about? We're going to go through week 3. After week 3 is done, what I suggest you do is do the WebAssign homework. Also look out for an email about this exam. It's exam number 1 and get the honor code to me. All right. So what are we going to do here in week 3? We're going to go through equations, like, review what you did in Math 100, like you've done lines, you've done parabolas and done circles. We're going to review domain and range, what you did in Math 100. Yep, it was tough in Math 100. Yep, it might be tough for you to do here as well. We'll go through examples though. We'll go through evaluations of functions. I'll go through these notes to the whiteboard later. We'll talk about the definition of a function. For the most part, students do find words very difficult. What I'm going to claim, though, is for the most part, I'm going to be visualizing what these words say. And we'll go through that. Again, for the students that want to watch little spot videos, they're embedded in the notes, and they may or may not be helpful. You decide what's helpful. The goal here is you need to learn the material. You need to learn this material, all right? Don't divide by zero, so that's a big concept. It's a concept that's been told to you in Math 100. Again, we'll go to the whiteboard with this later. We're going to talk about domain and range, and for the most part, domain's pretty easy to deal with because at this level of the game, domain basically says you're looking for those numbers that don't cause trouble. And what numbers cause trouble? Division by zero. And the other big avenue for trouble for you guys is even roots. Even roots, the radicand must be greater than or equal to zero. Okay, we have terminology. The terminology that we talk about, granted, when we write this stuff down, you may not understand what you've read. That's a problem. It's a big problem. It's a problem that's going to last a lifetime, by the way. Reading's difficult. It's difficult for everyone. Reading takes time. It takes effort. And I'm going to say that's really the foundational key of your education, your ability to read and understand what you've read. It takes time, though. So we talk about increasing function, decreasing function, constant functions. We talk about a concept of relative minimum of a function. Again, this notation may drive you crazy. We'll talk through it. Relative maximum of a function. We talk about even symmetry. We talked about that before. We'll talk about it again. We'll talk about odd symmetry. We talked about that before. We'll talk about it again. We'll talk about special points. I want to point out special points for me, really special points. Well, certainly what's known as an X-intercept, but X-intercepts are so special, they have multiple names. And what are the multiple names for them? We call them roots and we call them zeros, all right? We're also going to talk about average rate of change, which is essentially just slope between 2 points, stuff that you've done in Math 100. We're also going to discuss what's called a difference quotient. And again, we'll go through examples. So for the most part, the example should drive across the points. Lecture can be very dry for some students, though. A lot of students during lecture is they're basically tuned out and they don't hear anything. The key to this, though, is that you've got to start listening and moving forward in your education at some point. Otherwise, it's just not going to go forward. You'll stagnate. Graphing's tough. I do want to point out, I do prefer to use technology to graph, but the bottom line is we're not at that stage yet. We need to understand simple ideas when we're graphing out. And I want to tell you what those simple ideas are going to be. Basically, it's going to be finding X-intercepts, Y-intercepts, sign analysis, and getting a rough picture. And we will certainly go through that in detail. All right. We're also going to talk about using technology, but for the most part, technology is an afterthought after we can understand somewhat of what we're mentioning to you through these notes over here. So once we get through that, we'll go to example questions. These example questions, I mean, they take up a lot of room because there's pictures. So don't think there's a large number of large amount of information. There's not much information. We'll go to the examples. So I want to point out the examples seem really long to some students. All right. They're not. We can get through these really quickly, and we will get through them quickly. I'm not here to rush you through it, though. What I'm here to get you through it. All right. I want to get you through this material. We'll get through the examples. We'll do that together at the whiteboard. Then there'll be supplemental activities. What does that mean? Stuff that you get to do on your own. And that's where you should be looking forward to. After someone talks through this material, lecture, you should say, you know what? I want to try this too. I want to try. Well, you may have to go back and study the lecture, but the bottom line is at some point you want to try this stuff on your own. So what do? I give you an opportunity to try the problems on your own. That's what I give you an opportunity to do. I give you an opportunity to do that. Now, certainly, are you willing to take that opportunity? If you are, that's good news. If you're not willing to take that opportunity and simply say, I'll take the easy way out, I won't do anything, it's not going to bode well for you. You'll be in mystery land the rest of your life until you get busy. But again, this stuff will be done at the whiteboard and published at the end of the week. You can watch it off schedule. I don't know if I'm going to do it live or not. I'll get to that point later. But anyway, there's supplemental activity. All right, so you get through it. You will get through it too. I promise you, if you do work, if you're doing what we're expected to do, which is come to lecture and spend the 10 hours outside of lecture studying, you really have no problem finishing this course. We're not really teaching at a level where you can't finish it. Okay, so yeah, SAGE, certainly it's there. We'll talk about that as well. Technology, that's Sage for me. Then there's going to be review for exam number 1. So somebody looking at review for someone and say, oh, gee, you don't have the answers in video form for me to watch. Let me just go through that with you. There's going to be exam number 1. This is a review for it. There would be a set of problems there for you to work through. All right, a set of problems. So you go through the set of problems. Geez, let's take a look at that. And someone says, it's too much work for me. You got to say, I want to do something. I want to do this work. I want to get good at this. You've got to say that to yourself. But anyway, there's 13 review problems there, and I'll do that at the whiteboard as well. Again, I may do it live or just simply post a lecture for you. I am not at that stage yet, so we'll get there. So what I'm going to do now, I'm going to switch to the whiteboard. Give me a moment to do so. Okay, I'm at the whiteboard. And again, I want to point out, and certainly I don't want to read things to you, but some teachers, they will read things to you. They'll give you something and they'll read it to you. And there's nothing wrong with that. I'm just saying that I don't want to read it to you. I just want to paraphrase what's being said over here. So what I'm going to do is I'm going to blow this thing up, and we're talking through the equations over here. So someone says, what do you want me to know from Math 100? I can't say that you can remember everything in Math 100, but there's certainly some things you should remember. So for example, I'm going to say you probably should remember that you've graphed, some relationships in Math 100. What relationships did you do? You definitely graphed lines. And, for the most part, people like this form of line. The line is y equals mx plus b. How do you graph a line? Well, what you have to do is you graph 2 points, and then you draw a line through those 2 points. Fairly simple. Parabolas, you also did that in Math 100. The problems that you were given in Math 100 were rather simplistic. They were y equals ax squared plus bx plus c. What did you do in Math 100? Well, you did x-intercepts, you did y-intercepts, you did the vertex, and you did the axis symmetry. All right, that's important. You can remember that, but you may need to go back and review your mathematical material. You may need to. What else did you do? You did circles. And that was kind of the last thing you did in Math 100 as far as graphs go. All right, so circles were, fairly simple. It's a set of points that are equidistant from the center. And that was a distance form, is all it was. So that's the equation of a circle. And then what they ask you about these graphs when you got them, they asked things that might have seemed rather abstract to you. All right, they might have asked you, is it a function? Well, the bottom line, if you can solve for y in terms of x, you most likely have a function. So let me just emphasize that to you. So if you can solve for y in terms of x, you most likely have a function. So I'm just going to clip this off. This thing solved for y in terms of x, so y is a function of x. This thing is solved for y in terms of x, it's a function of x. Now this one over here is not functional. The reason being is it cannot be solved for y in terms of x. And the reason for that, if you try to do that, you would get plus or minus. And that's 2 different things, and we can't let that happen. However, I do want to say this over here. What I stated to you, that if you can solve for y in terms of x, it says you have a function. That's not entirely true. It's you most likely have a function. At this level of the game, though, we're not going to try to confuse you with that. So if you're given an equation and you can solve that equation for y, let's just say it's a function then, okay? Okay. What are you going to be asked about the function? Well, you're going to be asked a couple different things about it. You're going to be asked about its domain. And I want to emphasize what domain is, what you did in Math 100. Domain is the possible x values. So basically, you're looking for troubles. What kind of troubles do you have in Math 100? Well, you can't divide by 0. That's one thing. And the other thing you couldn't have done in Math 100, well, maybe you could, I say in the real number system you couldn't do it, is take the root of a negative number, an even root of a negative number. Okay, the other thing is going to be the range. Range is tough for students, and I want to point out why it's tough. It's the y values. So the domain is the x values, the range is the y values. The way we do this is visually, and we'll go through examples, all right? Notationally, what we do, we say y is a function of x. That's notational, right? We read it as y is a function of x, all right? So they're going to ask you questions about this. They're going to ask you about evaluation questions. So if you're given a function, this is a function over here, and you're asked the question, and I'll write it down for you. So you're given f of x, I'll write that down for you. And what's f of x? 3x squared minus 2x plus 1. And then they ask a question. And someone says, I don't even know what the question is. The question's f of 1. Well, in Math 092 and in 100, I think some of your teachers said, parenthesize the variable, and then plug the value of the variable in. And what's the value of the variable? 1. And now you're left with some arithmetic. So what do you get? 3 minus 2 plus 1, which is going to be 2. All right, let's do another one. And again, it may seem strange to you, but this is going to be f of 2 plus, I'm going to point something out to you. And this is something that you got to be very attuned to. When I type, the S looks like an S. If I were to write an S down though, unfortunately what happens to a lot of students, if I write an S down, it looks like the number 5 to them. So what I do is I use a cursive S, all right? So what do they want me to do? Parenthesize the variable, and then plug in the value of the variable. And what is that going to be? 2 plus S. 2 plus S. All right, let's do that one step at a time. You should be able to square 2 plus S, but if you can't, let me write down what you expect to do. 2 plus S squared is 2 plus S times 2 plus S. Now, I think that's easy, but you may not be in agreement. That's 4 plus 2S plus 2S plus S squared. So what's it going to give me? 4 plus 4S plus S squared. All right, let's do the next one. What's the next one going to be? Well, minus 2 times 2 plus S. Well, I can do that. That's minus 4 minus 2S plus 1. Again, I'm trying to remove all the symbols that I can remove and combine like terms. Well, I have a grouping symbol to remove now. What do you get? 12 plus 12S plus 3S squared minus 4 minus 2S plus 1. Well, you know what? I like to write this in order that you were given in Math 100, and that's descending order. So I'm going to start off with the highest degree variable. That's 3S squared. That's right here. Let's go to the S's next. 12S minus 2S is 10S. And let's go for the numbers, last but not least. 12 minus 4 is 8, and 8 plus 1 is 9. Now, do I make mistakes? All the time. And I want to point out, the reason I say that, you're going to make mistakes too. And if you make a mistake, fess up to it, correct it, try to learn from your mistakes. But the answers are listed over here for you. All right? So I'm going to say I kind of read through page 1 for you. And it wasn't that bad. It's just a review of what you've done in Math 100. Not much different. Really not much different. Let's go to the next page. And let's take a look at it. And I got to be honest with you for the next page. For a lot of people, it's word soup. They're reading it, and they really have no idea what they're reading. None whatsoever. All right? So my claim over here is that if you're reading it and you can't say what you read, well, you know what? Maybe you have to start rethinking what you're reading. All right? And let me see if I can do that for you. All right? So it says the definition of a function. And this is tough. Again, I could read it to you, you could read it to you, but if you don't understand what you've read, it's going to be really, really, really tough to understand it. However, this is the same exact definition that you were given in Math 100. Okay, what does it say? A function f from a set A to a set B is a relation that assigns to each element x in the set A exactly one element y in the set B. The set A is the domain of the function f, and the set B is the range. Again, I'm seeing these words again and again, domain and range. All right. You should note that the set B is not necessarily in the range. It just contains the range. All right. Characteristics of a function from a set A to a set B. Each element of A must be matched with one element from B. Again, this was covered in Math 100. There were exam questions on it, and you were given, you were graded on your ability to answer those questions. certainly as I'm looking at these things over here, sometimes that's really, really tough to understand what I'm reading. But I think if you keep reading the same thing over and over again, you might have a better impression of what you're reading, all right? So it says an element of A cannot be matched with two different elements from B. You might be rightfully confused at this point. So, I'm going to keep reading it. And Rich says not all relationships are functional. And that's true. Not all relationships are functional. There's plenty of relationships that are not functional. We'll keep it simple, though. So it says, why do you keep it simple? We want things to be really simple. We're not trying to complicate the picture for you. All right. Once again, you may need to be reminded that you should never divide by 0. So if you're asked to find the domain of this guy over here, let me circle it for you. What you're going to say, the domain is the x values. So the question is, who's allowed in? The way we say that is we say all the real numbers are allowed in, all real numbers except treble. What's the treble? When does the bottom become 0? When would we be divided by 0? Well, that's that x can't be what number? 3. All right, this is a fine answer. I want to point out we do write it a little bit differently under most circumstances. We use this what's called a Blackboard R, which is read as all the real numbers, comma, x not equal to 3. If you want to write interval notation down, the intervals would be from -infinity up to 3, not touching, union 3 to infinity, if you were using intervals. All right, you'll see me do that on occasion. All right, so I want to point out, which one's my favorite over here, the middle one. And the reason for that, it's so easy for me to write that down, but I have to be prepared to write it down in other ways. I do. All right, let's look at another one, a domain problem. And I want to point out, I'll write down what they want to know the domain of this guy over here. F of x equals the root of 4 minus x squared. And again, we'll go through many other examples, but they want the domain of that. So my problem over here is I don't see any division, so I'm not concerned about that. What I'm concerned about, though, is this is an even root. So the even root, the radicand, and the radicand is 4 minus x squared, must be greater than or equal to 0. Now, someone's going to say, I don't know how to do that. Well, if you don't know how to do that, you probably have not done the prior homework yet, because this is necessary. You have to do that. Now, how do we solve that? What we're going to do is we're going to factor it. It's already compared to 0. That's 2 minus x, 2 plus x. And if you've done the homework, this is very trivial. A number line goes down. What goes on a number line? The number minus 2. That's where one of the zeros is, and the other zero is at 2. What do? Take test values. Let me just say, for the most part, I've been practicing in front of you for some time, but we hope you went home and you spent the required amount of time to practice as well, and you should be getting better at it. So for example, if you plug in 0 and you plug in 0, what would you get? Well, 2 times 2 then, which is definitely a positive number. So that's good news. That's greater than 0. If you went past 2 and you tried like 3 and plugged it in, you would get a negative times a positive, a negative number. And the negative numbers are not greater than 0. If you went below minus 2, like for example, minus 3 and plugged it in, the first factor would be positive, but the second factor would be negative. Overall would be negative. What's the other question? Is it ever equal to 0? Yeah, between minus 2 and 2. All right. So I'm gonna write down the domain of this guy over here. That's D. The domain goes from minus 2 up to 2. That's interval notation. I could also write it down this way over here. Minus 2 to 2. There are a variety of ways of writing it down, including graph of it. Now, why is domain so important? If I were to graph this problem, the picture would only be between minus 2 and 2 inclusive. And that's really nice to know, because my picture of this function would only take place between minus 2 and 2. And this is a picture of f of x. This is the x-axis, this is the y-axis, and the y-axis is f of x. All right, let's take a look. Let's take a table of values down, all right? So I'm gonna graph it, and we're graphing out f of x. And what's f of x? F of x is the square root of 4 minus x squared. Well, I know it starts at minus 2. If you plug in minus 2 to the function, I want to point out the functions over here. What would I get? I would get 0. And I think the last point would be 2. If you plugged in 2 in the function gets 0. So I got 2 nice easy points over here. And lo and behold, what are those points called? They're actually called X-intercepts. That's pretty easy. What's the other point going to be? Well, there's other points, but how many points are between -2 and 2? An infinite number. I'm just going to pick one, and I'll pick the number 0. And what would 0 be? Well, if you plug in 0, what you get? You get the square root of 4, which is 2. Well, isn't that convenient? All right, so that's 2. Let me tell you what this point is here. It's an X-intercept. And what's the X-intercept? 2, 0. This is an X-intercept. Whoops, let me get my eraser out. This is an X-intercept, and its point is -2, 0. This over here is a Y-intercept. And what's the Y-intercept? 0, 2. Now, I realize somebody says, I don't have that connects together. We'll talk about that in more detail later, but I'm hoping you realize there is some connection between those. You should also realize the square root is always going to return a positive number. So if I were looking at that, I would, again, I'm certainly more experienced than you guys over here. It's actually a semicircle that connects those 3 points together. Now, someone's going to say, I don't really think that's a semicircle. Your picture's not very good. We're not looking for great pictures. We're looking for moderately good pictures. That's it. And it's what's known as a pre-calc sketch. All right. So I'm going to say that, don't get your brain in a bunch over this material. And the number one reason is that we're going to keep it simple. Okay. We're going to keep it really, really, really simple. Let me just outline what I just said. Don't get your brain in a bunch over this. We'll do the material by example, and there's very little to remember. And a lot of what you've done in Math 100 is going to translate over. All right. Let's talk about some words, and words have consequences. And so you're going to be asked about these things, but again, you may be confused. We hope that confusion leaves as we start doing examples. But we're going to look at increasing function. We're going to look at decreasing function. We're going to look at constant function, and we'll just do those first 3 first, right? It goes on to say a function f is increasing on an interval if for any x1 and x2 in the interval where x1 is less than x2 implies that f of x1 is less than f of x2. Let people read that, and they really have no idea what's been said. I'm going to paraphrase it, though. What does it say to me? It says, as you're moving left to right in the function, if you're going up, it's increasing. And repeat that. An increasing function means this. As you're moving left to right on the function, is it moving up? Yes, it's increasing. Decreasing says this. I could read that to you, but I'm going to paraphrase it. As you're moving left to right, if the function is moving down, it's decreasing. I want to go back to my picture over here. I'm going to talk about that. All right. So I'm going to say this function f of x is increasing on the open interval. Well, as you move left to right, where's it going up? Only between -2 and 0. I want to point out what I mean by that. As you're moving left to right, we're moving along the x-axis. The x's are moving to the right, but the y's are going up. Okay. It's increasing on the interval, and this is an interval of x's because we're moving left to right from -2 to 0. F of x, and again, we'll go to other examples, is decreasing. As we're moving left to right, the function is moving down. It's falling down. And where's that interval going to be? 0 to 2. Let me point that out to you. As you move left to right, this function is moving down. What's the left to right motion? X to 2. X goes from 0 to 2. All right? So I'm going to say, it's not too bad. We'll go to other examples. And I guess we're going to talk about constants now. This doesn't happen too often, but it says a function f is constant interval. And I'll tell you what constant means. It's not moving up. It's not moving down. It's flatlining. What does the flatliner look like to me? Horizontal line. It's not moving up. It's not moving down. All right, let's talk about relative minimum of a function. This is going to be sticky business from now to the end of your careers. Whoops, sorry about that. Very sticky. I'm hoping that it's not going to be so sticky you can't get the thing removed, that you can actually think about it. It says a function value, f of a, is called a relative minimum of f if there exists an open interval. Let me point out what I mean by open interval. If there's an open interval that contains a such that f of a is less than all other points on that interval, we will go through examples to illustrate that point. It must be contained on an open interval. Let me go to the picture over here. And what I'm going to claim over here, some people say, oh, I think I know what you mean by minimum. And I'll point out what they think this over here. I want to tell you this can't be a relative minimum, and I'll tell you why. It's not contained in an open interval. In other words, there's no values to the left of 2. This could not be considered a minimum, a relative minimum. The reason being, it's not on an open interval. There's no points over here in the graph. Can't be. All right. I know that's confusing, but anyway, let's not worry about what you're confused by. Let's see if we can remove those confusions by just simply, looking at examples. Here's the deal, though. I really can't say this enough times. Lectures can be incredibly dry for students. You need to study the material, though. You need to find an interest in something that you're willing to study. All right. This isn't something that I want to just get through it and hope this is over soon. You're thinking about moving forward. I hope you are anyway. All right. Relative maximum function. And again, it might seem difficult, but for the most part, it's really not that bad. We'll go through examples and relative maximum. Relative. A function value f of a is called the relative maximum of f if there exists an interval, open interval, by the way, x1, x2 that contains a. Well, you know what? I'm going to go back to the other picture for you. And I want to point out that other picture looked like this over here. I'm going to draw the picture down. I'll put the points down for you. These are points, by the way. That was minus 2, 0. This is 2, 0. And this is going to be the point 0, 2. All right. So I'm going to point out to you there is an open interval that contains a point that appears to be bigger than all their points. So the open interval is here. In other words, you could draw an interval around this point that's open. Now, what does an open interval means? There's something to the left of it and something to the right of it. And what's going to be the relative maximum there? It's going to be this point over here. What's the relative maximum going to be? 2, where did it occur when x equals 0? All right, let's keep moving through. And as I move through these things, we're hoping at some point you want to study these things. So let's talk about a function with even symmetry. Well, this comes from really the prior section, but now we got function notation. So I'm going to say a function even symmetry if we have this condition being met, that f of x equals f of minus x. But I want to read it to you. It says a function f of x is said to have even symmetry or y-axis symmetry, folding symmetry. So this is a good example, the picture I have over here, of a problem that's even symmetric. And what I mean by that, I'll write that down for you. F of x was equal to 4 minus x squared. My claim is over here. It's the same thing as f of minus x. What would that give you? 4 minus, parenthesize the variable, minus x. And what does that simplify to? Well, here's what I noticed, that they're basically the same thing. F of x and f of minus x are the same thing. It's definitely got even symmetry. What does that mean, folding symmetry? Well, I'm looking at the picture and I see the folding symmetry about the y-axis. Let's talk about odd symmetry. Odd symmetry, okay? A function f of x is said to have, and we've talked about this in the last section, is said to have odd symmetry or origin symmetry if for each x in f's domain, f of x equals minus f of minus x. That's an important fact, by the way, and that's a test we used last time. Hoping you remember that. Right? I'm hoping you remember that. Special points. I hate the fact that anything's called special, but there are special points, and we'll talk about those things. A function f of x has a y-intercept if 0 is in its domain. So what do? Just set the x to be 0. You get a y-intercept right over here. X-intercepts, okay? A function f of x has an x-intercept if 0 is in the range. What does that mean? Well, if 0 is in the range, it's got an x-intercept. Makes sense to me. It's the x-axis, all right? And what's that going to be? Well, the x-intercept is going to be the form a such that f of a is equal to 0. And we'll go through examples. X-intercepts are so important, they have multiple names. What names do they have? Root and 0, all right? Average rate of change, basically just a slope problem. What is this thing over here? It's basically just slope of a line. So if you took a line over here, and I'll put this over here, you have a, f of a, that's a point. Another point over here, b, f of b. What's m? Well, it's going to be f of b minus f of a over b minus a. That's the only thing that's written over here. It's basically just slope between 2 points. That's it. Now, granted, a line doesn't have to go through that, but a slope of a line through those 2 points. So I'm going to say average rate of change is just slope. That's all it is. All right. Next up is what's called a difference quotient. And again, we'll go through examples. Difference quotient. This is a difference quotient. All right. Let me just briefly go through that, what that looks like to me. We have 2 points now. I'll write this down over here. X, f of x. And what do they put over here? Another point over here. And this seems strange to a lot of students. It's x plus h, comma, whoops, f of x plus h. All right. What's slope? Let's write this down for you. F of x plus h minus f of x over the change in x, which is x plus h minus x. Well, this thing simplifies to f of x plus h minus f of x over h, with the understanding that h can't be 0 because you can't divide by 0. All right. So I'm going to say that these two are related, that these two here are essentially the same thing. All right. Let's talk about graphing. As I go through the graph, I want to point out it can get tough. So tough, in fact, that we have troubles with it. If you have troubles with it, I have no objection to using a machine. And you're going to see most of my graphs have been generated by using a machine. I'm going to go to the next page, though, and we're going to talk through this graph. All right? We're going to talk through this graph. By the way, a picture's been given to me, and I'm glad a picture's been given to me. The first thing I would recommend you do when you're given something to graph is write down what they want you to graph. And what do they want you to graph? They want you to graph f of x equals x cubed minus 3x squared minus x plus 3. Let me go through the steps we'd like you to follow if you can. You may not be able to do this, by the way. The first thing we'd like you to do is see if you can factor f of x. Sometimes it's impossible, but this is something you did in Math 100. What'd you do in Math 100? Well, those 4 terms, you'd factor it by grouping. So x squared would come out in the first 2 terms, and you would get x minus 3. Then you get minus, what comes out from the next 2 terms? Just the number 1. And what do you get? X minus 3. You should check that this is correct. X squared times x is x cubed. X squared times minus 3 is minus 3x squared. Minus 1 times x is minus x. And minus 1 times minus 3 is plus 3. That worked beautifully. Then what do? Well, there were 4 terms. Now there's 2 terms. Those 2 terms have a factor in common, x minus 3. What's left off? X squared minus 1. Continue to factor it. What do you get? X minus 3, x plus 1, x minus 1. And this is f of x again. All right? All of them are f of x. The gold standard of graphing, though, was getting really nice points down. And I want to point out, although it may not be a great picture like a machine, I think we get a really good idea understanding this, if we can. So I'm going to put a table of values down for you. And I'm going to put down x and y. And I'm going to start taking points for you. And so what point you're going to pick? Well, I'm going to tell you the easiest point I could pick is probably 0 for x. And where would you plug it in? To the actual function. all right? So let me point out, if you put 0 in, what would you get? 0, 0, 0, oh, 3. Pretty simple. Put this over here. So I'm going to put that point down for you. 1, 2, 3. It's right here. That was simple. Let me go for another really simple point. And the other simple point I'm going to look at my factored form. Look at this form over here. And I'm going to look at it. I'm going to say probably 3 would be easy. And why is that? If you plug in 3, this becomes 0. If you plug in -1, this becomes 0. And if you plug in 1, this becomes 0. So I'm going to put them down. I like to put them in order, by the way. So -1, 1, and 3. And what would I get over there? Well, if you plug in -1, you get 0. If you plug in 1, you get 0. And if you plug in 3, you get 0. So I'm going to plot those points down for you. -1 right here. And then I get 1 right here. And then I get 3. All right. Now someone says, what are you going to do? Well, I can't say this enough times. It's sign analysis is what's going to determine if this thing is positive or negative. So let me just tell you what, after here, what would be a good number after 3 to choose? 4. We'll plug it in. What do you get? Positive, positive, positive. So what do I now know? After 3, the function is positive. It's above the x-axis. I may not know exactly what it looks like, but I got an assumption that as the numbers get bigger, this will get bigger and bigger and bigger. Now let me go between these two numbers. And what's a good number between those? I'd say 2. And if you plug it in, what would you get? Well, that would be a negative number, right? Positive and a positive. So overall, it'll be a negative number. All right. So I'm going to say that there has to be something below the x-axis here. Now, if you want between these two values, I've already got a test point. It says it's positive. Now, by the way, I don't know exactly what it looks like, but maybe something like this over here. I'm not saying it's right. I'm saying maybe it looks like that. I'm not sure. Maybe it looks like that. All right. This was known as a pre-calc sketch. Now, if you go below -1, what would be a good choice below -1? I would say probably -2. If you plug in -2, negative, negative, negative. Overall, it's negative. What does that mean? It's below. So I'm going to say this is a rough pre-calc sketch. It's rough. All right, let's go to the better picture. All right. Now someone says, why do you want to go to better picture? It's better. It's better than what I did. All right. But I'm going to look at it. And I'm going to point out this goes on forever in that direction. This goes on for that direction. Did we get these right? We sure did. I want to point out my graph is not correct though, but it's good for a pre-calc sketch. What did I miss? I missed points, and I want to point out the points I'm missing. I don't know what that is, and I don't know what that is. And there's no way I can get that from my graph. By the way, there's no way I can get it from this graph over here. So what I want to claim over here, they told me what those points were. All right, let me go through that with you. And I want to go through very carefully what they're saying. They say it's increasing from -infinity all the way to -0.15. That means it's going up until it gets there. So I want to point out what that point is there now. All right. And by the way, they told me that. So I'm going to tell you the point now. This point over here is -0.15, comma, f of, let me get my eraser. I realize I ran a room there. Or you know what? Let me just back away from it. That's that point there. All right. By the way, they also say it's increasing. Let me go back over that from 2.15. And again, we're moving left to right, and it keeps going on forever. So I know this point now. What's this point over here? It's 2.15, comma, f of 2.15. So one says, could you compute the number? I'm not interested. We can compute it though. It's around -3. The other one's around 3 point something. All right. So I'm going to say we got this part covered. Let's go to decreasing now. It's decreasing on the interval from -0.15 to 2.15. Well, that seems reasonable. I'm seeing the picture. It's decreasing here. It's going down, right? Now, someone says, where'd those numbers come from? Don't worry about it. They've been given to you. Okay, let's keep going. Is it constant? Well, looking at it, it's constant nowhere. It's either always moving up or always moving down somewhere. Okay? Never constant. What's the relative minimum of the function? I want to circle it for you. This is the relative minimum. Why is that? It contained an open interval. Now, by the way, they did the computation for you. And I want to point out this point here is this point over here. This is the relative min. All right. All right, let's go to the next one. And what's the next one going to be? Maximum of the function. And where does that occur? Let me circle it for you. It's over here. And what is that point? Well, I mean, looking at the picture, it is a little bit above 3. They did the computation for me. I want to point out where that is. That's right here. What's that point? Right up here. This is the relative maximum. What do I mean by that? It's on an open interval, and that point's bigger than all other points in an open interval. Are there other points bigger than that one? There are, but we're just looking at an open interval to see that. Even symmetry? No, not even. I'm looking at that. I don't see folding axis symmetry, y-axis. Odd symmetry? No, I'm not seeing that. What are the special points? Really simple, y-intercept and the 3 x-intercepts. All right. So I'm going to claim over here that, for the most part, it's nice to have a computer to do these things, and I'm not opposed to it. But most stuff we're going to do is do by hand. All right. And that's where we're going to go to next. We're going to go back to the whiteboard, and we're going to start doing examples. All right. Thank you.